Alright, hey there, how's it going guys? So what we're going to be doing today is we're going to be solving equations because I love solving equations. But today we're going to have something weird happening in our equation. And that's going to be these absolute value bars that we're going to be seeing in all of the equations today. So there are a few steps that we have to handle before we can really work with this. Because we want to still solve for, we're still trying to solve the riddle, what is x? But in order to do that here, we're going to have a couple of steps. Our first step is going to be isolate the absolute value. Alright, so in this case, this one's already isolated, so let's go ahead and bring it down. That's step one. Okay. The next thing that we want to do is we want to remember that absolute value, those absolute value bars, absolute value is always going to equal a positive and a negative. So we're going to change the other side to a positive and negative. We're going to split it. So number 2, that's a 2, split other side into positive and negative. That's a posi and neg. So let's go ahead and do that. So we're going to write the 2x minus 4 equals 12, or 2x minus 4 equals a negative 12. We make the entire side negative. Alright, and so number 3 is going to be to solve both. And really what I like to do is kind of like do the same steps in both of them. But today we're going to just go about it one by one. So step 1 is going to be add 4. So now I have 2x equals 16. And then divide by 2. That equals 1. So x equals 8. And then normally, yes, I will box this, but we're going to leave that unboxed right now because we're not sure if that's going to be my answer. And the process is going to be the same over here. So add 4, that zeroes out. I get 2x equals negative 12 plus 4, that gives me negative 8. Divide by 2, that equals 1. X equals negative 4. Because step 4 over here, that's going to be check your solutions. And you're going to want to do this every single time you have an equation. And these rules that we have over here, these are going to be true for all equations. The only thing that we're going to do for inequalities is just the checking. We're not really going to be checking because there's a set of answers that we can't really check them all. But over here we're going to check it. So let me switch my color to the checking color. I'm going to put in, so I have the absolute value of 2 times 8 minus 4, close absolute value. Does that equal 12? That's my question. So 2 times 8, that gives me 16, still in the absolute value. Again, does that equal 12? And then the absolute value is 16 minus 4, well that's 12. The absolute value of 12 is 12. Does that equal 12? Well, yeah, it does. Okay. Now back to the other side. Absolute value of 2 times a negative 4 minus 4. Does that equal 12? Question mark. Let's check it. So 2 times negative 4, that's negative 8. I don't know where that 1 came from. Minus 4. Negative 8 minus 4, that gives me negative 12. And then the absolute value of negative 12, well, that's a positive. Always changes it to a positive. Does that equal 12? Yeah, it does. All right, so that's our check, and we get all the way through to the end. So we know now we can put them into boxes that those are going to be 2 of my answers. All right, let's move on to our next one. All right, so in this example, we had a negative of the absolute value of 4 minus 8x equals 12. So step 1 is going to be isolate your absolute value. So divide by a negative 1. So I'm going to divide by negative 1 on both sides. So now I have the absolute value of 4 minus 8x equals negative 12. Well, if we remember absolute value, oh my god, all of this should have been blue. I'm sorry, but we'll leave it in red for this one because this is a no can do. This we can never equal a negative number when you have absolute value. You can never say like the absolute value of x equals negative 3. There's no negative distance. You can never have negative distance. Well, sir, if I'm walking backwards, that's negative distance. I'm taking it away. No, you're still making positive distance. You're just doing it in a weird way. So this is not possible. And our solution, everyone's like, okay, I'm done, right? No, your solution is no solution. If you leave it blank and you're like, oh yeah, there was just no solution to it. No, tell me that there's no solution. All right, let's move on to our next one. Whoa, what a beast. Okay. Still is going to be our same steps. Isolate the absolute value. So divide by 7, divide by 7. So now I have the absolute value of 8 minus 3x equals 21 divided by 7. That gives me 3x. And then 49 divided by 7, that gives me 7. 3x minus 7. All right, now I can split it up. So I'm going to have 8 minus 3x equals 3x minus 7, or I could have 8 minus 3x equals a negative 3x minus 7, close parentheses. So I put that in parentheses because I want to show that it's the entire side that becomes negative. And now I just want to solve. So let's see. Let's add 3x here, add 3x here. Okay, that zeroes out, and then add 7 here, add 7 here. That zeroes out, and I'm left with 15 equals 6x. Divide by 6, divide by 6. 15 divided by 6, let's simplify. We can put 3 into both of those. So 5 over 2 equals that, equals 1. So 5 halves equals x. Great, fractions, freak out. I'm just kidding. All right, here we want to distribute our negative number. So, 8 minus 3x, that stays the same, equals negative 3x plus 7, just switches the signs of what's in there. Our next step, again, you're going to add 3x, add 3x. That zeroes out. Oh, that cancels out too. So now I'm left with 8 equals 7. Whoa, did I do something wrong? No, I didn't really do anything wrong. What happened here is, they just cancel each other out. So basically this side is dead. There's nothing to do here. So right now I only have one solution to check. So let's go ahead and check that solution, 5 halves, back into your original. You always want to use your original. You don't want to use anything that was changed. Always go back to your original. So I have 7 times the absolute value of 8 minus 3 times 5 over 2. All right, equals 21 times 5 over 2 minus 49. All right, let's see how good Mr. Hernandez's fraction work is. Let's just tackle this. So I have 7, 8 minus, 3 times 5, that gives me 15 over 2. Okay, equals absolute value. So 21 times 5, yeah, the 2 can't cancel that out easily. So let's see. 21 times 5, that gives me a 5, and that gives me a 10. Okay, 105 over 2. Jesus, look at this problem. All of these fractions. Minus 49. Oh, right. Ooh, that might actually work out nicely. All right, so I'm going to rewrite this. Let's see. Teal, that seems like a good color. All right. We can write this as 16 over 2. That's still 8. But now I can subtract it. So now I have 1/2 in there times 7 equals 105 over 2. Let's see, what can I do with this 49? I could double that. So 49, that's going to give me a 98 over 2. 105 minus 98, that's going to give me 7 over 2. Now this absolute value right here, that's going to stay the same. Positive 1/2, so 7 times 1, that gives me 7 over 2. Well, does that equal the same thing I had on the right side? Yes, it does. So check. Go ahead, circle this. I am breathing so hard because that was such a long problem. We had to go through this and it just like nothing worked. Like I thought I had messed up. And then we had to go through this and we had fractions and we had to bring up everything from everything we've done up to this point was in this problem. So this is actually a beautiful problem. I really like this. I might put it on my next quiz. All right. Now let's move on. Let's see what we have next. Whoa, this one's a little bit different, but not really. The only thing that's different is that I have this inequality right here, and there's a step 2 kind of changes a tiny bit, but not really. So step 1, we want to isolate this absolute value. So divide both sides by 3. So that equals 1, and now I have the absolute value of y minus 9 is less than 9. Okay, so here comes the nifty trick. What I like to do is I like to drop my absolute value bars. Y minus 9 is less than 9. And then I want to keep this sign right here. So I want to keep it and I want to bring it down over here. Less than still. And then a negative 9. Now this isn't really like, yes, this is a less than, this is a less than in the context. But what I'm saying is y minus 9 is less than 9. And also y minus 9 is greater than negative 9. I could have written it both ways. But now we just want to solve, add 9. But now we have so many sides we have to do it on, but we're doing it all at once. It's okay. So this piece we get 0 less than y less than 18. And that's it. That's all you have to do is just bring it down, hold on to that sign. And let's go ahead and graph this. Let's see how this looks when we graph it. All right, so switching back to red, my checking tool, my checking color. All right, so here's 0. Here's 18. Now, this is going to be an open circle because this is just less than. But now I'm saying I want all the y values that are less than 18. Okay. All right, so all those values that are less than 18. But then over here it says, also my y values need to be greater than 0. Okay, well, all of these ones I've circled are greater than 0. Okay, greater than 0, greater than 0. Boom, stop. These ones, if I go any further, they're not going to be greater than 0. All right, so it's only going to be this section that we're going to have. So you really got to read this compound inequality in order to puzzle out what you're going to be writing. Let's move on to our next one. Excellent. We have a different sign. That's good. All right, step 1, you want to isolate your absolute value. So add 4 to both sides. So now I have the absolute value of 3x is greater than 12. All right, and remember what I said, we want to hold on to this symbol and split it up with the negative. So drop the absolute value, it still says greater than 12, but then hold on to that symbol, drop it down, and it becomes a negative 12 now. All right, what happens now is we're going to divide by 3 on every side. That equals 1, so I'm left with x. Hold on to my symbols. 12 divided by 3, that's 4. Negative 12 divided by 3, that's a negative 4. So let's go ahead and graph this out. My checking color. Alright, so I have negative 4 over here. Then I have 4 over there. All right. And again, open circle because it's only greater than. All right, but all my x values need to be greater than 4. Okay, so that's what I'm reading right here. All my x values in this portion, they're saying they're greater than 4. So going off my line a little bit, these are all greater than 4. But then this piece right here, that one says it's less than negative 4. If I read it backwards, x, all my values for x are going to be less than negative 4. So I want to go this way. And you just want to satisfy both of those when you're writing your compound. And so in this case, we're going to shade the outside. So again, you want to keep that symbol facing the same way, but you want to read your compound inequality in 2 parts. I think I got a couple more up here, so let's jump into the next one. Again, at any point, if you're ready, just go ahead, pause it, and then check your answer with me. So we're going to go ahead here. This one's already isolated, so ooh, that's beautiful. Okay, so let's drop it down. Negative 2x plus 1 is greater than 2. Same sign, negative 2. Okay. Let's see, subtract 1 on both sides, on all sides. That zeroes out. 2 minus 1, that's 1. I still have a negative 2x. And the negative 2 minus 1, that's negative 3. And now, kind of a wonky part, divide by negative 2. If you remember your inequalities, whenever you multiply or divide by a negative number, so not that one, this one right here, it flips your sign. So I'm going to divide by negative 2 here, divide by a negative 2 there. And so it's going to flip our signs on both sides. So now this one's going to say less than negative 1, negative 1/2, and greater than 3/2. So let's see how this one turned out. So if you're paying really close attention, my sides, my lower number and my higher number changed. So this one's going to take some trick. It's not really a trick. You just got to be careful when it comes to this one. Alright, so here is my number line. I'm going to put negative half, negative 1 over 2, and then 3/2 over here. 3 over 2. You know, zeros right around there. Open circle because it's only less than. And then, so my x values are going to be less than the negative 1/2. So all the values that are less than negative 1/2. Then all my values that are going to be greater than 3/2. So let's check it. All my values that are greater than 3/2. These are all of my answers. So, 2 is over here. Let's check 2. If I put 2 in here, negative 2 times 2, that gives me a negative 4 plus 1. That gives me a negative 3. Absolute value negative 3. That's 3. 3 is greater than 2. That checks out. And let's check something over here. Let's check, here's negative 1. So if I put in negative 1, so negative 2 times negative 1 plus 1. So that gives me 2 plus 1. That gives me 3. 3 is greater than 2. All right, perfect. Again, let's check one of these ones that aren't in our set. So let's, here's 0 right there. Let's pick 0. All right, so negative 2 times 0 plus 1. So that's 0 plus 1. That's absolute value of 1. So that's 1. Is 1 greater than 2? No, that didn't work out. So, if you're not sure about the steps that you were doing, you can always go back and check your answer. Check numbers that are in the solution set. And now, I think I got one more. Oh, yeah, I wrote this one separately. I kind of wrote this one out. Let me bring it down a little bit. I wrote this one separately because I had that fraction bar and wasn't coming up nicely on the computer. But let's go ahead and tackle this one. First thing, isolate your absolute value. So x plus 5 over 3, absolute value. We're going to add 3 to both sides. Now it's greater than 9. Our next step is to hold on to our sign. X plus 5 over 3 is greater than 9. Facing the same way, but a negative 9 now. So multiply by 3 everywhere. We were dividing, so now that equals 1. 9 times 3, that gives me 27. Negative 9 times 3, that gives me negative 27. It's funny how these numbers always kind of match up, but that's the nature of it. And now we want to subtract 5 on both sides. So 27 minus 5, that's 22. Here's my x. Negative 27 minus 5, that's negative 32. Alright, so those are my values. Let's just quickly get this on a graph. And actually, I'm going to quickly change this problem. If it said greater than or equal to. Just because I didn't put in an example like that, but I'm going to put it in now. Here's 22. Just a quick sketch. Here's negative 32. Since it's greater than or equal to now, solid circle. That's solid. Good job. Alright. My x values are going to be greater than 22, so these are over here. And then my x values are going to be less than negative 32, so those are over here. So you can pick any one of those. Those are all going to be your solutions. Alright, so that concludes this lesson. Again, if you need any help, just let me know. This is Mr. Hernandez, and I'm always here to help.